Hello everyone, myself Rana Tadi, studying in Dayanand Sagar University in Electronics and Communication Engineering. Today I will be sharing the knowledge and skills I have gained during this internship. Throughout the program, I have learned the fundamentals of C and C++. I have learned about a deep understanding of embedded systems and IoT, Internet of Things. I have completed the project on home automation. Starting with the basics of C, I have learned about data types. Are of two types, integral and floating point. Next, qualifiers. Qualifiers are also of two types, constant and volatile qualifiers. Constant qualifiers are used to declare variables which values cannot change after initialization. On the other hand, volatile qualifiers tells the compiler that the value of a variable may change unexpectedly. Next, conditional constructs. Conditional constructs can be of single iteration if and its family switch statements or of multiple iteration. For example, for loops, while loops and do while loops. Next, we learnt about operators and their precedence operators are of many types like logical operators, assignment operators, bitwise operators, ternary operators. We were also taught about the precedence and associativity of operators. Next, arrays. Arrays store multiple values of the same type. For example, it can be an integer array that store all integers. It can be a character array which stores all the characters. Next, we have pointers. Pointers store memory addresses and point to the memory address. Next, we have strings. Strings are character arrays. String manipulation are also in detail to us. Next, taught in detail to us. Next is storage classes. Storage are like auto, static, define variable scope and lifetime. Next, header files. They organize function and macro declarations. Next, we have header files. Header files organize functions and macro declarations. Moving on to C++, what we learned in basics of C++. In the first thing we were taught was the difference between C and C++. So the major difference between C and C++ is that C uses POP, that is procedure oriented programming, while as C++ uses a OOPS, that is object oriented programming. Concepts of OOPS include classes, objects of classes, access modifiers, that is private, public, constructors and destructors. Next we have is pillars of OOPS. We have 4 pillars of OOPS: encapsulation, abstraction, inheritance and polymorphism. And all these 4 pillars is what makes C++ a unique language. Next we have is virtual functions. Under virtual functions we have learned about static linkage, dynamic linkage and runtime polymorphism. Virtual functions allow dynamic linkage, enabling runtime polymorphism, where the appropriate method is chosen based on the object type at runtime. Next we have is C++ features namespace is an abstract space that is used to organize code and avoid name conflicts. Next we have is STL, standard template library. Standard template library provides reusable classes and functions. Next is print functions, access private members, abstract classes, provide a basis for other classes with pure virtual functions. Next we have is templates. Templates helps us to write generic programs. Templates are of 2 types, function templates and class templates. Next we studied about exceptional handling. Exceptional handling is is operated on 3 keywords, basically mainly try, catch and throw. Try is used to test the code, catch is used to handle exceptions and throw is used to generate an exception. And exceptions are handled during the runtime. Next we have is IoT, Internet of Things. Internet of Things is unique objects connected to internet. There are objects refers to devices but not people. Also here we observe bidirectional communication and large amount of data flows. The data is very complex that is flowing. Let us now move on to the embedded system. Embedded system is a combination of hardware and software which is intended to do a specific task. For example, washing machine, TV, smartwatches, Wi-Fi, automotives, etc. Categories of embedded systems. Embedded systems are of 3 or 4 categories: standalone, real-time, networked, and mobile. Standalone embedded systems follows instructions blindly, takes decisions on its own without human intervention. Example: self-driving cars. Second, real-time. Real-time embedded systems completes tasks within a given deadline. If deadline is missed, then the hard real-time, soft real-time, and firm real-time are taken upon respectively. Third, network embedded system. Network embedded system help in getting connected. For example, router helps in connection purposes. Fourth, mobile embedded system. Mobile embedded system is movable and is designed especially for smartphones. Next, we move on to components of embedded systems. So we were taught about components of embedded systems, and there are 8 components of embedded systems. First, microcontrollers, microprocessors, SoC, they are used to process the code. Second, memory. We will given in detail knowledge about the memory. Types of memory, that is mainly RAM and ROM, and further we were taught about the types of RAM and types of ROM, and we were taught about hybrid memory. Types of RAM include SRAM and DRAM. Types of ROM include PROM and EPROM. Master ROM. Third, sensors. There are again 2 types of sensors, analog and digital sensors. Fourth, actuators that converts electrical energy to mechanical energy. Fifth, human interfaces. Example: switches, input, and screen for output. Sixth, FPGA or ASIC. For example, timer. Seventh, diagnostic port. It monitors embedded systems. Eighth, auxiliary system. It is used to cool the devices so that they do not heat up. Next, we were taught some basic programs. So these programs led to the foundation of our project because we already learned these programs. They helped a lot in our home automation project, and they were the building blocks for our project. So these were some of the basic programs we were taught to write on a Arduino and implement on PiximLab. These were the softwares we used. The programs are: first, how to write a program to toggle LED. Then write a program to print hello on CLCD on first line. Then WAP to read value from temperature sensor and display it on the CLCD. Fourth, write a program to test analog write function. Fifth, WAP a program to brighten control brightness of LED with LDR. Sixth, write a program to control the inlet valve and the outlet valve. Next, we move on to the home automation project. This home automation project was the center of this internship program. We were required to build a home automation project. We were taught about how on building the project. This project automates multiple things we use in our homes in daily life. For example, garden lights, heater, coolers, cereal tanks. Let us have a look at the project. The softwares used for the project were Arduino, PiximLab, and Blink IoT. Arduino Uno is a board we use for writing code for the project. Second, PiximLab is the simulator used to execute the code for the project. Third, Blink IoT. Blink IoT can control hardware remotely. It can display sensor data, it can store data, and it can visualize data. Blink IoT, we were supposed to install the apps on our application of Blink IoT on our mobile phones, and then we ourselves controlled the devices remotely using our mobile phones. We will just show in a while. Next, we have is project requirements. So what all were the project requirements? First, guardian lights control. So read the LDR sensor value and vary the brightness of the LED accordingly, which resembles the controlling of guardian lights based on the availability of sunlight. Second, temperature control system. Read temperature from LM35 and display it on CLCD. Third, cooler control system. Detect the change in the logic level. If the button widget is at logic high, turn on the cooler. If the button widget is at logic low, then turn off the cooler. Fourth, similarly, we did cooler control system, we did heater control system. In that we detect the change in the logic level. If the button which has it high logic, then turn on the heater, and if the button which is at low logic, then turn off the heater. Fifth, threshold temperature control. It stated that if the temperature exceeds 35 degrees Celsius, then you have to turn off the heater and send the respective notifications. Sixth, volume of water. To display the volume of water present in the tank on CLCD. Seventh, inlet valve control. If the button widget is at logic high, then turn on the inlet valve. And if it is at logic low, then turn off the inlet valve by sending commands through serial communication. Next we have is value control, and it is similar to inlet valve control only. If the logic level is high, then turn on the outlet valve, and if it is that logic low, then turn off the outlet valve by sending commands to serial communication. Ninth, we were supposed to control the volume of water in the tank. If the volume of water in the tank is less than 2000 liter, if it is less than 3000 liter, then turn on the valve and send the respective notification. So this requirement wanted that whenever the volume of water exceeds a specified limit, then the inlet valve should be turned off and the no more water should be flowed into the tank. Here are some code snippets. So this is the major code we used. These are the some just snippets. I will be showing full code in a while. And this is how an initial output we can say look like. These are the devices we used for example, this is LED, this is the LDR, this is CLCD. In this temperature is shown. This is our Ethernet. This is our cooler, heater. Now let us look at the real implementation of the project. Let us start with the code file. Now this is my final code project file. Initially you can see I have defined multiple variables, authentication token, template ID, template name. I have included multiple header files like SPI.h, Ethernet.h, Blink Simple Ethernet.h, Wire.h. Also, there are some header files which are here, main.h. It includes multiple pins, variables. Similarly, we are LDR.cpp. LDR.cpp where we are writing the functions for init LDR, for brightness control. We have main.h, we have here pins and gauge defined. We have serial tank.cpp, that is multiple functions to enable and disable inlet and outlet valve. We have serial tank.h having multiple variables and functions defined. We have temperature system.cpp. Similarly, we have temperature system.h. Now we have included all the header files respectively. Now let us move on to the code. You can see the blink write function over here. So what this blink write function is doing, it is controlling the cooler. As you can see, the cooler switch is taking input, and if the cooler switch is true, then we will turn on the cooler and we will print the cooler on thing on our CLCD. Similarly, if the cooler is off, if the value is false, then we will print cooler off. Then we will turn off our cooler. So this is how we are going to control our cooler on and print the respective function on CLCD. Similarly, we have written the blink right function for heater V pin. If the heater switch through, then the heater will turn on, and else it will turn off. Then we have the function update temperature reading. What this will do updates the temperature. Next we have is the handle temperature. The handle temperature takes the control of the handling temperature beyond 35 degrees Celsius. So whenever our temperature exceeds 35 degrees Celsius, the heater is turned off. You can see the heater control off, and CLCD we are printing heater off. So the requirement that stated that if it exceeds 35 degrees Celsius, then you have to turn on the heater. This is the function that is fulfilling that requirement. Next we come to the inlet valve. If the inlet switch is true, then we will enable inlet. We will set the cursor and we will print on the CLCD inlet flow on. Else we will disable the inlet. We will stop the flow and we will print inlet flow off. So this is for the cereal tank which we are controlling. Similarly, we have written the blink right outlet function. In this also we are enabling and disabling the outlet valve accordingly. Next we have is the handle time function. We are controlling the volume of the water if the volume of the water exceeds a particular limit. In this we have used 3000. If the volume of the water exceeds a particular limit, we will print inlet flow off and we will stop the flow of water in the tank. This is how we control the flow of water in the tank. Next we have is the setup function. So setup and loop. These are the basic functions of an Arduino file. Okay, so here we have called all the functions. This was all about the code part. Now let us look at the execution. This is my PixSim. This is the spare parts we have used in our project. Let me load my hex file. I have loaded the file into the board. Now let's see. Now you can see the home automation written here. As you can see, the LDR bulb the temperature and volume is also shown. So this LDR sensor and LED, these two showcases the garden light control. You can see as soon as I am varying the values of LDR sensor, you can observe the change in the brightness of the LED. See, the LED is turned off as I reduce the value of LDR. And as I am increasing the value of LDR, it is getting brighter and brighter. So this is basically resembling the garden lights, how actually in real life garden lights work. That if the sunlight is more, if the sunlight is more, then garden lights will be off. But if sunlight is less, the garden lights will turn on. We used LDR sensor and LED. Next, we have our cooler, heater and cooler temperature system. You can see heater pin, cooler pin, temperature pin. For this, we will use the Blink IoT application. Before that, I would like you to show the Blink console. I would like to show you the Blink console. Here we have the project name Home Automation. We have the data streams here. As you can see, the heater, temperature, cooler, volume, inlet valve, outlet valve. Now let's see this is the Blink IoT app. As you can see, if I turn on the heater, you can see the temperature rising. As it reaches a minimum temperature, it will automatically start to cool down. Now I will turn on the cooler. As you can see, the cooler is turned on. Also, the green light here, it shows that our app is turned on. Now let me show you the water tank inlet. You can see as you can see, this is our cereal tank. As you can see, if it is reached 3000 liter, the inflow off, and it has reached automatically, inlet valve was turned off automatically. This was the whole of our home automation project, controlling the cereal tank, controlling the temperature, controlling the heater and cooler switch systems, controlling the green lights. Now I would like to conclude my project using Blink IoT. I would like to conclude my project using Blink IoT application and Pixim Lab simulator. We simulated home automation where LED temperature system, cereal tank resembles light heater control, cooler water tank in real time. CLCD acts like a dashboard used for displaying the events and widgets from Blink IoT app. Like button widgets are used to control heater, cooler and inlet valve and outlet valve. Widgets were also used to display the temperature and volume of the water. Thank you. At last, I would like to thank you, the whole Emertex team. Thank you, Jayalakshmi ma'am. Thank you to all the teaching staff, all the teachers who taught us each and every concept in detail, in depth. Thank you so much. I have never learned Internet of Things, IoT, embedded system, home automation in such detail in my life. Each and every concept was explained multiple times and clearly. The home automation project was so nice to work on. Discovering PixSimLab, Arduino Uno, Blink IoT application was very interesting and exciting throughout. Thank you so much for the unwavering support and this opportunity. Thank you so much. Thank you.